এটা ইন্ডিয়ান জার্নাল অফ ইকোনমিক্স একটা হসপিটাল না কোনো ঠিক নেই না না ওটা ঠিক নেই বলা বাড়ির যেমন না ওদের ওদেরটা ঠিকঠাক এবিডিসি তো সিতে আছে
Okay, good afternoon, students. Now we have Dr. Sushmita Chatterjee. She is the assistant professor of Monindo Chandra College, Kolkata. And she is expert in structural equation modeling. So I have invited her to enlighten us about the structural equation modeling. So now it is over to Sushmita. Sushmita, please.
Thank you, sir. Thank you for inviting me. Good afternoon. Good afternoon, participants. Am I audible?
Yes, ma'am. Good afternoon.
So today I am going to deliver lecture on confirmatory factor analysis, thereafter structured equation modeling. And I will also discuss how to perform equation modeling by using R software. The screen is visible or not?
Ma'am, nothing. It's blank screen.
এটা হচ্ছে না visible participant screen sharing ওখান থেকে করে দিন এটা allow multiple sharing Didi, full screenshot. Slide,
Ma'am, now it's visible. Now your screen is visible, ma'am.
Can you read?
Yes, ma'am.
Okay. So I will discuss exploratory factor analysis, variance and covariance matrix, then factor analysis model, model implied covariance matrix, explanation of path diagram. Then I will also discuss one factor CFA, the parameters and degrees of freedom. Then 3-item one factor analysis, identification of 3-item one factor in confirmatory factor analysis, and running a one factor CFA in R. Then in today's plan, we also have model fit statistics, model chi-square, and approximate fit indices, confirmatory factor index, Tuckle-Lewis index, and root mean square error approximation. So this is the overview of structural equation modeling. Let us start with exploratory factor analysis. Exploratory factor analysis, where we are exploring the factors, the latent factors of our model. And in confirmatory factor analysis, we have a priori model with us. We have to confirm the theory and the a priori hypothesized model. In structural equation modeling, we have the factor analysis part as well the regression part. Now, I think all of you know about factor analysis. Am I right?
Yes, ma'am.
So I will just give the brief overview of that. Factor analysis is the name given to a group of statistical techniques that can be used to analyze interrelationships among a large number of variables and to explain these variables in terms of their common underlying dimensions, which is known as factor. The approach involves condensing the information contained in a number of original variables into a smaller set of dimensions with a minimum loss of information. In more technical terms, factor analysis addresses the problem of analyzing the structure of the interrelationships or the correlations among a large number of variables like test scores, test items, questionnaire responses, by defining a set of common underlying dimensions known as factors. Now, the principal component analysis considers the total variance which can be derived from the factors that contain small proportions of the variance, and in some instances, the error variance. Specifically with component analysis, we are interested in the diagonal of the correlation matrix so that the full variance is brought the factor matrix. Conversely, with common factor analysis, communalities are inserted in the diagonal. Communalities are estimates of the shared or common variance among the variables. Factors coming up from common factor analysis are based only on the common variance. Common factor and component analysis models both are widely used. The selection of one model over other is based on two criteria. The first one is the objectives of the factor analysis, and the second one is the amount of prior knowledge about the variance in the variables. The component factor model is appropriate when the primary concern is about prediction or the minimum response of factors needed to account for the maximum variation of the variance represented in the original set of variables. And
Ma'am,
when,
excuse me.
yes,
Ma'am, sorry to disturb you, ma'am, but some words of this PPT are not visible in the starting. Like, I think it's been zooming too much, has been done, or is it something else?
okay. Share. Data হবে না তো হচ্ছে না তো। Now is it clear?
Yes, ma'am. Yes, ma'am. Now it's clear. And ma'am, I'm really very sorry for interrupting you in
No.
between. Now it's clear, ma'am. Now it's readable and it's fine, ma'am.
Common factor analysis suffers from the problem that several different factor scores can be calculated from the factor model. Results, in other words, there is no single unique solution as found in component analysis. Now, I will show you a particular example of this. Say there is a 16-item scale. That is, we have 16 questions in the questionnaire. The research is for deciding upon the technology readiness index. So there are some statements, some optimism statements are there. The first statement is like this: new technologies contribute to a better quality of life. Can you see this properly?
Yes, ma'am. Yes, ma'am. It's visible.
Now, the second question, technology gives me more freedom of mobility. The third question is technology gives people more control over their daily lives. The fourth one is technology makes me more productive in my personal life. Now, there are innovativeness statements and the scale is in Likert scale, 5-point Likert scale. Now, I will show you how to perform the factor analysis in R. So these are the commands. Can you see the R window?
No, ma'am. Screen is gone. Screen has gone black.
Okay. Hmm? Yes. Now it is visible.
Yes. Yes, ma'am.
So first you have to import the data set. Now I have the data set. Can you see this?
Yes, ma'am. So I have imported the data set. Now this is the command for doing the factor analysis. What is the command? FA for factor analysis, then factorial. ISI 23 is the data set. And how many factors? I am giving the command for 2 factors. Any one of you doing this on your own? Now, is there anyone? Is there anyone doing the factor analysis now? Maybe I am facing some technical problem over here. So I am showing you the R scripts.
So first, you have to pull the data. Then the command is factorial, then the data and how many factors you want. Thereafter, you have to check the uniqueness of these variables and you will get the loadings. So you can see the loadings of the factors. Here, for factor 1, we have this OPT1, that is optimism statement 1, optimism statement 2, 3, and 4. These 4 statements are having higher loadings. And for factor 2, this innovativeness statement 1, 2, 3, and 4 having higher loadings. So we can specify 2 factors with particular loadings.
Yes, ma'am.
The uniqueness, sometimes referred to as noise, corresponds to the proportion of variability which cannot be explained by a linear combination of the factors. So, a high uniqueness for a variable indicates that the factors do not account well for its variance. Now, if you can see the mathematical model, this is very simple. In this particular mathematical model, we can see this y is the dependent variable and x is the independent variable. And this epsilon is the error term. And if this is the basic model, you have several such y's, y1, 2, 3, like that. And the first part of this matrix is the constant part. Lambda 1, lambda 2, lambda 3, these 3 are factor loadings. Eta 1, this is the factor, the latent factor. And this epsilon 1, epsilon 2, and epsilon 3, these 3 are measurement errors. So one thing should be remembered, that this eta 1 is the factor, not the item response or the variable. This is the factor, and item responses or the variables are y1, y2, and y3. So we have 3 basic regression equations: y1, tau 1 plus lambda 1 eta 1 plus epsilon 1. And just following the basic regression model, we have other 2 equations as well. So all these equations are representing measurement models. Measurement models.
Okay, ma'am.
Then don't be afraid of all these equations. This is very simple as regression equation. So there is a particular model of estimated parameters. Estimated model, the left-hand side is the estimation. And these are all just factor loadings and the error term. Now in path diagram, we can symbolize latent variables by this circle, observe indicators or items by rectangle, intercept, paths, and covariance matrix. Now this is the measurement versus covariance model. As I have shown you, this Y1 indicated by this eta1 factor. So Y1 is nothing but the variable or item response or a particular questionnaire indicated by the factor eta1, and the factor loading is nothing but the correlation or interrelationship between the factor and the variable. And there is also one measurement error, and the estimated value is theta1. So epsilon 1 and eta 1, these two are indicating y1. So the direction is from eta 1 to y1 and from epsilon 1 to y1, not the other way around. So these are all linear equations, and the covariance is shown by the blue line, the covariance. So these are all, the linear equations are all measurement models. Linear equations are all measurement models. Now, we will go for one factor confirmatory factor analysis. Now, as we know, for the latent factor optimism, we have 4 indicator variables or observed indicators known as optimism 1, 2, 3, and 4. As I have shown you the questionnaire before, we have 4 questions for this latent factor optimism. So this is one factor confirmatory factor analysis. Now, this is the R code for detecting the covariance. Now, I am giving the R script. And this is the R script where the 4 factors, 4 items are given, and the covariance structure is this. I will share you the scripts as well.
Ma'am, screen not visible.
Yes. Now hope you can see the screen. Is it okay?
Yes, ma'am.
Yes. So this is the command. Now, again, I will go back to the theoretical part of this. Now, to calculate the total number of parameters, we have to follow this rule of thumb. P plus 1 by 2. For 3 items, it is 3 multiplied by 3 plus 1 by 2. So this is the structure of the confirmatory factor analysis with loadings lambda 1, lambda 2 and lambda 3 and the estimated parameters theta 1, 1, 1, 2, 1, 3. If you could, I will again show you the structure. So now you can see for lambda 1, lambda 2, lambda 3, theta 1, 1, theta 2, 2, theta 3, 3, the diagonal items, and theta 1, 2, 1, 3. These two are second and third item in the first row. So this is the structure, measurement versus covariance model. So now you can see the total degrees of freedom can be calculated by this very simple formula. Now for fixed parameters, predetermined to have a specific value. Fixed parameters are predetermined to have a specific value. So lambda 1, lambda 2, lambda 3, all set to 1. Diagonal items are all set to 1. And off-diagonal items are set to 0. So number of free parameters is equal to number of unique parameters minus number of fixed parameters. Number of free parameters is equal to number of unique parameters minus number of fixed parameters.
Ma'am,
Yes.
ma'am, in that previous slide, it was written that whenever we see the if we want to define the free parameters, its number of free parameters is equal to number of unique parameters minus fixed parameters. What are unique parameters?
Those are having factor loadings which you are not fixing.
Okay.
Okay. Now, degrees of freedom. Number of known values minus number of free parameters. Number of known values minus number of free parameters. That calculate the degrees of freedom in our model, and according to that formula, it is 6. P plus 1 by 2. Now, degrees of freedom will be negative if known parameters less than free or parameters. That is, you cannot run the model. If degrees of freedom is 0, then known parameters are equal to free parameters. That is, just identified or saturated model. So there also you will not get any kind of model fit. Now, degrees of freedom will be positive if known parameters are more than free parameters. That is over identified model, and there only you can assess the model fit. Now in 3-item CFA, this is 3-item CFA. So only one factor is there, but 3 items or indicator variables are there. Now, this is the method of identification of 3 items, and where we put the first loading of each factor to 1. First loading of each factor to 1. This is the marker method. This is the marker method. Now, variance standardization method fixes the variance. Slide number 18. Okay.
Ma'am, there is also some another question in the chat box. I think it was asked by some other participant in the chat box. It's their question.
Okay. If yes, the model, the first one is, I think it is Varsha. If degrees of freedom is negative, that means there is no factors. There is no factors, not that, but the model is not identified model. And this is slide number 18. Yes. Is there any question about this? What is the question regarding this slide? Yes, we have to use another model. Exactly. We have to use another model. And is there any question about this slide?
No, ma'am.
So factor predicting item and factor variance is shown by this covariance symbol. Now, this is variance standardization method, fixes the variance of each factor to 1, but freely estimating all loadings. Now, I will do the 1 factor 3 items CFA in R. And we'll give you the scripts as well. These are the scripts to perform the one factor CFA in R. Now I will show you the R Studio now. And after giving these commands, the results. So the first command is this one. So I am giving instruction to R to make a model. I am giving the name M1A. To optimism is the latent factor and indicating optimism 1, 2, and 3. So this is the R script. So this is the R script for modeling this optimism by 3 indicator variables. Optimism 1, optimism 2, optimism 3. Is it visible and clear?
Yes, ma'am.
The next command is one factor 3 items CFA. CFA of which model? That M1A model. And I have chosen the data set ISI 23rd. This data set. So this is the second command. The third command is summary one factor 3 items, that is A, and this is the result. Number of observation and the estimates are given. From the p-value, you can see. So in estimate, you can see for optimism 1, the estimate is 1. So the factor loading is 1 for the first indicator variable, and for other two, it is 0.833 and 0.513. And both the indicators, optimism 2 and 3, both are statistically significant. You can see the p-values. Up to this clear? Or is there any question?
No, ma'am.
I can hear only one voice. So this is performing the CFA in R. Now we will go for hypothesis testing, which is very important for confirmatory factor analysis. So what is the hypothesis for confirmatory factor analysis? The hypothesis is the estimated model is equal to the hypothesized model. This is the hypothesis. So the sample variance covariance matrix, which is S, is equal to the estimated model, which is capital sigma hat. Sample variance covariance is equal to the hypothesized or estimated model. So here we have to accept the hypothesis. That is good. Now, measures of fit in confirmatory factor analysis. Approximate fit index is, absolute fit index is root mean square of error of approximation, and incremental, one is Tucker-Lewis and other one is this CFI. And model fit chi-square is also very important. So what we have to check when we have to report the results? One is RMCA, then CFI, then TLI, Tucker-Lewis, and the model chi-square. Now, RMCA is nothing but this delta by degrees of freedom n-1. And what is delta? That is chi-square minus degrees of freedom. Now, when you have to report your results for your paper, for your research, if this RMCA is less than or equals to 0.05, then it is a close fit, a good fit model. Between 0.05 and 0.08, reasonable or moderate fit, and greater than or equals to 0.1 is a poor fit model. So if your model is having this RMCA value less than 0.05, then it is a very good fit model to report. Thereafter, criteria for fit. The model chi-square maximum likelihood, the confirmatory factor index, that should be closer to 1, between 0.9 and 0.95, like that, a good fit. Tucker-Lewis is also, if it is tending to 1, that is a good model. Higher values or greater values than 0.9 is a good fit. And RMCA is the root mean square error of approximation. So for close fit or good fit model, it should be less than or equals to 0.05. Now we can perform two-factor confirmatory factor analysis as well. I have one question in chat box. Slide 37 for numerator RMCB take chi-square. Yes. The chi-square value will be calculated. Observed minus expected. Yes. Is there any other question? Till now? Now we can perform two-factor confirmatory factor analysis, three-factor, four-factor. So you can extend your model and you can generalize for n number of factors. So this is the path diagram for two-factor factor analysis. Is there any question? No.
Ma'am, how do we know that chi-square will be a fit model for this? Because it was written in the previous slides that uh, other two models were also given, and this kind of model is exactly a fit, like chi-square. It's been given in the box in the
Okay.
previous.
So when you have to report your results and you have to prepare your research paper, these are all indicators. If the chi-square value is not that good, then you can see what about your CFI, TLI, and
Mm.
above all, what is the situation of your RMCA.
Mm-hmm.
So it may happen when you are doing this. You are from which field? Psychology?
Yes, ma'am. Yes, ma'am.
Okay. So you have a big item response scale, say for 70 items, 90 items, you have to meet different respondents with different views. It may happen that your RMCA may tend to 0.08 or 0.09
Mm-hmm.
particular situation for a particular focus group.
Mm.
And it may happen, it is in maybe in India, but in some other situation, in some for other respondents, it may be 0.05. So it depends. You cannot just approve or disapprove any model according to
Okay.
your fit indices.
Okay, ma'am. Okay.
So you may get some counterintuitive results as well, as we all see in our primary surveys. So you just cannot disapprove of your model by just one indicator. You have to see all the other factors or all other indices as well. That's why I am telling you for now, for internationally authenticated research as we have to see or we have to look into all these indices. It may happen one index or one
Mm.
uh, the fit index may not applicable or may not giving you a very good result, but all other indicators are giving you
Mm.
that you can go on with this particular model you have hypothesized.
All right,
Okay.
ma'am. Ma'am, thank you, ma'am. Got it.
Now this is correlated factors where we have taken the optimism and innovativeness. These two factors, latent factors. And this is the R script for performing the two-factor correlated two-factor solution model. Can you see the R script?
Yes, ma'am.
So you can do the CFA by 8 items and 2 factors. Now for uncorrelated two factors, this is the script. Now for, you can see for correlated factors, this is the marker method correlated two-factor solution. And for uncorrelated two-factor solution, we have to give this script. That is F1 and F2, these two are not correlated to each other. Now, the fit, you can give this command to see the fit and summary of the fit. And we will get the estimate like this. So this is the command, and thereafter the result is this. As we have gone through the marker method, the first factor is getting the loading of 1 and other factors are getting different loadings. Now all factors are statistically significant. Now for plotting this, you have to install packages SamePlot. These two are R scripts for the same building. So you will get a diagram like this, where you can see the covariance between optimism and innovativeness. So this is the command and this is the result of the command. Now for fit measures, this is the command for fit measures. So CFI, confinement fit index, RMCA, then upper bound and BIC is given. So CFI, you can just check the CFI and RMCA. That is very much needed for your paper publication. Now I will move to structural equation modeling. Up to this, is there any question? I think no. So I will take just 2 to 3 minutes and then I will start the introduction to structural equation modeling. So now you can take a break and give the answers of the questions given in the first session and in the Google form.
Google Classroom.
Google Classroom. Please send your answers in Google Classroom.
Correction. Correction. আস্তে আস্তে করে হ্যাঁ
করবে তার কাজে লেগে যাবে মেয়েটা যদি পেয়ে যায় পুরো তার কন্ট্রাক্টর সমস্ত কিছু করে নিজেই করে নিতে পারবে
তুমি কি মঞ্জু জানতে পারছো?
হ্যাঁ মনে হয় তুমি পাস আউট হয়ে গেছি ইউনিভার্সিটি থেকে এমএসসি
আচ্ছা ওখান থেকে এমএসসি করছো,
কমপ্লিট হয়ে গেছে
এমএসসি কমপ্লিট করে ফেলেছো?
রেট এক্সাম ছিল তো রেটটা ক্লিয়ার হয়েছে তাই ম্যানিফেস্টেশন
আচ্ছা ওকে ওকে
Am I audible now?
Yes, ma'am.
Oh. Hmm. So one question is there. Can we do this in a SPSS instead of R script? So then the answer is yes, you can do this in Amos as well. But in Stata, in Amos, in these softwares. But for this workshop, we are targeting to let you know about our scripts for doing factor analysis, performing confirmatory factor analysis, as well as structural equation modeling. Hope you got
Okay,
that.
ma'am.
Okay. Now, we will start with the structural equation modeling. It is nothing but, again, a simple linear framework which models both simultaneous regression equations with latent variables. Models such as linear regression, multivariate regression, path analysis, confirmatory factor analysis, and structural regression can be thought of as a special cases of structural equation modeling. Now the measurement model. As we have already discussed the measurement model, it is a multivariate regression model where the predictor is an exogenous or endogenous latent variable. Exogenous or endogenous latent variable. So we have already seen such a measurement model. Say for optimism, the first item, the first question of the optimism scale is the dependent variable, and the latent optimism is the independent factor affecting the variable, the first question of the optimism scale. So this is the basic structure of the measurement model. So X-side indicators are there, vector of intercepts are there, vector of latent exogenous variables are there. Now, vector of residuals are also given. And this delta, capital delta matrix of loadings, and that theta delta, the variance and covariance residual. So this is a simple multivariate type regression model. Now we can get the covariance structure. Now, the most essential component of a structural equation model is covariance, or the statistical relationship between items. Between items. The true population covariance, as I have already shown you for the hypothesis testing, the true population covariance denoted by capital sigma is called the variance covariance matrix. Since we do not know about the sigma, we can estimate it with our sample and call it sigma hat. That is the estimated variance covariance matrix. And it is equal to S, or the sample variance covariance matrix. As I have already told you that this should be equal to each other. That is the estimated variance covariance matrix and sample variance covariance matrix. So in structural equation analysis or structural equation modeling, we want to equalize these two. The function cov specifies that we want to obtain the covariance matrix of this sample variance covariance matrix from the data. The cov command in R allows us to obtain the S. Now, the structural regression model. So we have already discussed the individual components that make up the structural regression model. So if we can recall, the multivariate regression involves regression with simultaneous endogenous variables, and path analysis allows for explanatory endogenous variables. Confirmatory factor analysis is a measurement model that links latent variables to indicators. Latent variables to indicators. That is, optimism is a particular latent variable. It is linked to indicators optimism 1, 2, and 3, as we have done previously. Finally, the structural regression unifies the measurement and structural models to allow for explanatory latent variables, whether endogenous or exogenous. So the first equation is a measurement model, a multivariate model. Second one is also that. Now you can see in the second equation, eta is the independent variable. So working as an exogenous one. Now, in the third equation, where it is the whole structural model, where eta is working as endogenous variable, that is the dependent variable in this equation, as well as the independent variable. So in structural modeling, the structural regression unifies the measurement and the structural models. So here the descriptions of different expressions in the equations. X side indicators, Y side indicators, latent exogenous, latent endogenous. These are all names of the symbols. Now, structural variables, vector of intercepts, matrix of regression coefficients, matrix of regression coefficients of latent endogenous as well as latent exogenous, and the vector of residuals for the latent endogenous variable. And assumptions are that eta and this xi are not observed. Epsilon and delta are errors of measurement for y and x, and epsilon is uncorrelated with delta. So measurement errors are uncorrelated, and endogenous latent and exogenous latent, these are not observed. That is latent in character. Now the R codes, these are the R codes. Say for optimism, we have 4 items. For innovativeness, we have 4 items. There are 2 other indicators as well. That is, one is risk, that also having 4 items. And this RIS is depending upon optimism and innovativeness. Then you have to fit the model, and thereafter you will get the summary of the model. So these are the R codes you have to use. Now these are the results, where you have the test statistic, comparative fit index, Tucker-Lewis index, then root mean square, error of approximation. These are the very basic indices you have to report. Now these are the R codes for performing a particular structural equation modeling. So up to this, do you have any question? And if you are doing hands-on or now, then with your data set, you can perform any question up to this? No. So here I have a particular data set. In that data set, the adoption intention, this ADO latent variable is having two items, adoption intention 1 and 2. And adoption of a particular entrepreneurship depending on the marketing availability and material availability. And marketing availability, this MAA variable latent is having 3 items, and this material availability is also having 3 items. And this adoption, particularly this latent, is having 2 items. Now, this adoption is depending upon marketing availability and material availability. So this is the model. So the first 2 measurement models, first 3 measurement models, and the last one is the structural model, where you can see the endogenous variable, this marketing availability and material availability. These two are now exogenous variables, exogenous latents. So this is the particular structural model. Now you have to fit the model according to the data, and then you have to get the summary results. So I can send you the particular data set with the R script so that you can do on your own and you can see the results. So when you do this, you will get the results like this. So comparative fit index, then TLI and RMCA. You have to check all these. So this is the result for the structural model as well. So factor loadings are given, and then the regression result. In regression result, you can see the estimates. That is nothing but the coefficient of regression. That is the relationship between adoption and marketing availability. And from the p-value, we can see there is a good covariance between adoption intention and the marketing availability, as well as with the material availability. And the covariance between marketing availability and material availability, that is also significant. Now the rule of thumb, the ratio of sample size to the number of free parameters. It is 20 to 1. That is, for one free parameter, you need 20 sample size. Now, for a very small sample, or when you don't have a large sample base, then it can be 5 to 1. Now, 200 sample size is very good for same research, or it will be adequate. So lower sample size can be used for models with no latent variables, models where all loadings are fixed, models with strong correlations. Now, for models with about 75 to 200 cases, the chi-square test is generally a reasonable measure of fit. So you can get your answer as well. Someone was asking that, what about the chi-square test? So the models with about 75 to 200 cases, the chi-square test is generally a reasonable measure of fit. But for models with more cases, the chi-square is almost always statistically significant. The chi-square is also affected by the size of the correlations in the model. The larger the correlations, the poorer the fit. For these reasons, alternative measures of fit have been developed. What are those? Incremental fit index. So an incremental fit index is analogous to R square, just as for regression equation. And so a value of 0 indicates having the worst possible model, and a value of 1 indicates having the best possible. So the researcher's model is placed on a continuum, and this is the formula. So you don't have to bother with the formula, but you must look into the fit index. And if it is closer to 1, then you can see and you can say that your model is a good fit model. Now, the worst possible model is called the null or independence model. For confirmatory factor analysis, the usual convention is to allow all the variables in the model to have variation, but no correlation, and to have free means and variances. The degrees of freedom for this null model are k minus 1 by 2, where k is the number of variables in the model. Now, the null model, when there are causal paths, would be to have all exogenous variables are correlated, but the endogenous variables are uncorrelated with each other. And the exogenous variables, the degrees of freedom for this null model are k minus 1 minus p minus 1 by 2. K, number of variables in the model, and p, the number of exogenous variables or indicators in the model. Now, comparative fit index. This incremental measure is directly based on non-centrality measure. Null model of D of null model minus D of proposed model by D of null model. If the index is greater than 1, it is set at 1, and if less than 0, it is set to 0. If the CFI is less than 1, then the CFI is always greater than TLI. CFI pays a penalty of 1 for every parameter estimated. Because the TLI and CFI are highly correlated, only one of the two should be reported. So it will be better to report CFI rather than TLI. But if the RMCA, that is error of approximation, is less than 0.158,
there is no reason for calculating CA5 because there will be a very small CA5. So this is the calculation of RMCEA. And again, I am harping on that fact that RMCA should be less than or equal to 0.05. Now, you can go for standardized root mean square, residual, and Akai information criterion. So these are the standard indices you have to look into when you are getting the results of structural equation modeling. Is there any question about this theoretical part of structural equation modeling?
No, ma'am, but requesting you to play that CFI slide again previously, which you were playing. That slide, please.
Yes, this one.
Okay, ma'am. Okay. Mom got it, ma'am. Thank you.
Okay. So I am ending today. And if you have any question, please.
Dear students, I hope that is you have enjoyed today's two classes and you do not have any question more. So please go to the Google Classroom and answer as quick as possible.
Hi, sir. I want to ask one general question
Yeah.
that psychometrics is a very unpopular field in India. Like, not many people know about it. So, what do you think is the future of psychometrics? Like, will many courses be available for us to take, or some colleges will conduct these programs on psychometrics?
No,
What is your vision?
first observation, psychometrics is not the unpopular. The students
Okay.
of psychology, they are learning psychometrics, okay? Because whatever they are doing in the practical, they cannot avoid psychometrics. Psychometrics is there. Only this is the advanced applied psychometrics, and very few people have some idea about this advanced technique. But the common pattern everybody knows. Even the not only the psychologists, but also the students of economics, students of management, uh, even the computer science students, now they are also learning psychometrics. In ISI, our BStat students, they are learning psychometrics. So psychometrics is not the uncommon. And Professor Prashant Chandra Mahalanovich, he initially brought psychometrics to the Indian Statistical Institute. And gradually we are moving. But whatever you are learning here, this is not very common to all the faculties even, because we have given the knowledge about the advanced applied psychometrics. You are in TCS. TCS is involved in different type of testing and related to the selection. Now TCS is thinking about the psychometrics.
Yes, sir. I'm also learning psychometrics in TCS.
Yeah.
Okay, sir. I got the point. Thank you.
Yeah, it has very high prospect, very good prospect. এটা কি তোমার ল্যাপটপের? I'm requesting all of you, please answer to the question given in the classroom so that we can select the candidate to whom we can give the certificate.
Sure, sir.
Decide by using Google.
Akshita Bindal, I have given you some suggestion. I think you have received.
Yes, sir. I'll just check.
I have given some suggestion to you. You go to the Google Classroom and there you can find the assignment. And do not answer on the question given. Okay. Separate answer you have to give. এই তুমি এটা সরাও।
Yes, sir. ওটা তো খুলে আনতে হবে দাঁড়ান।
বলো।
এই রে,
এটা কি হলো?
তুমি তো অফ করে দিলে। এটা কি হলো?
কি করে?
অফ করলে বন্ধ হবে না তো কি হবে? যাক, বেঁচে গেছে।
Direct ইয়ে করে।
তুমি কোশ্চেন দিয়েছো?
এসে দিচ্ছি।
Sir,
Yes, lovely.
sir, the space where our assignments have been attached, like where questions have been written. So, can't we answer in the classroom comments? Because the thing is that yesterday when someone was asking, you said that you don't have to attach anything. I mean, any kind of doc, Google Doc or anything.
You can
So
write. You can just write down. Okay.
I think there is one option of private comment there. Maybe we can use that.
yeah, just sir,
No,
I have that only. So is it fine?
no. Here I find some of the students like Akshita Bindal, they have given separately. So I find everything, their name is there. Madhuri Nandi, she has also given. But Madhuri, you have, I cannot read anything because all things are totally black. I do not know how I can read. বেশি কোশ্চেন দিও না।
না গ্রুপে দিয়েছি।
এই তো Farah Ahmed has given. Just now, madam has given 2 questions to you. Please you check. Suppose I have not received anything from you.
Sir, I have pasted in comment section.
Comment section pasted.
And the last MCQ, I have given the answers in the private chat.
Good evening, sir. I have completed all the assignments. So kindly, can you please check?
Okay, dear students, you will get the assignment number 4. Okay, technical session 4. Just now you have received the question related to the ACM. এই টুকরোটা কি লেখা আছে? CFI is equal to D normal. এগুলো কি?
হ্যাঁ, বি এক্ষুনি পড়ালাম ওকে। বি নাল মডেল মাইনাস বি প্রোপোজ মডেল
Okay, dear students, am I audible to all of you?
Yes, sir.
Yes, sir.
So this is the valedictory session. Please share your experience about what you have learned and the teaching strategies that we have followed. After that, we will declare the name who will get the certificate from us. So before that, I am requesting you to say a few words about our teaching for last 2 days. Okshita, I'm requesting you, please you say a few words.
Yes, sir. So it was a great experience learning about the SEM model, the art script, and understanding the use of psychometric testing. Also, it was very good to expand our knowledge base from various teachers who have dedicated their efforts and brought everything on a single platform. Thank you so much for giving us the opportunity to learn from you, especially you, and bringing everyone together so that we can understand how to perform better in the research and get results. That's also thank you.
Thank you, Akshita. Now I am requesting Ananya Agarwal. Ananya, please share.
Hi, sir. So I was able to relate the classical test theory and item response theory with my work, and I was able to make a connection. This learning will surely help me in my work. And I also want to uh, especially mention about your session that it was very interactive, the way you were giving exercises and giving us activities while teaching. That was very helpful for us to get engaged in that session. So yeah, I liked this workshop very much, and that's all from my side. I learned a lot that will apply in my work, in my job. Thank
Thank you. Thank you, Ananya. Now requesting Rambabu. Hello, Rambabu Moria.
Yes, sir.
Please.
Yeah. Sir, it was a very good session. And right now, as I'm working in TCS and the project is totally related with the psychometric, so I connect all of session with my project work. And it was a very good session that was delivered by you and ma'am. And I hope it is very, in future, it is very helpful for me. Thank you, sir.
Thank you, Rambabu. Barsha. Hello, Barsha. Are you here?
Good evening, sir. Yes, sir, I'm here, sir. Sir,
Okay,
it
please.
was a very good and very informative session.
Hmm.
Very helpful, sir. Yes, I have to go and look into many more details of it, sir. But it was really good what I was looking for, what I required. So thank you, sir, and thank you for your team. And actually, it was made very simple, and in very simple terms, it was being explained so that we could understand it very well. Thank you, sir.
Acha, Barsha, we have not received anything from you in the Google Classroom.
Yes, sir, I'm doing, sir. Actually, from mobile, I'm doing, so it is taking more time, sir. I'll do it and I'll submit it, sir.
Okay.
Sir, yesterday I pasted my answer on a public comment, but right now I pasted my all answer in a private comment. I did not got.
We have evaluated your comment.
Okay,
Thank
thank
you.
you.
Shikar.
Good afternoon, sir.
Good afternoon.
Good evening, sir. Good evening, everyone. It was actually my first workshop in statistics, and I had very basic knowledge in statistics. And going about this orientation program, it was actually beginner friendly, sir. So I was able to attend properly, and I was able to do the activities with the full fledged reflection and it was very helpful for me, sir, because I am actually doing a paper for a conference on tool construction, and I am hoping to use all the cluster analysis and factor analysis. And I have learned about R script. I didn't know about something called R script itself. I was totally what to tell. Totally, I was involved. I was using only SPSS, and from now on, I'll try how to do statistics with the help of R script. Sir. Thank you so much for providing me the insights, sir. I'm looking forward for more such workshops.
Thank you. Acha, whether your name is Ramya Shekhar,
Ramya Shekhar, sir.
R-A-M-Y-A, right?
RAMYA, sir.
Okay. Babita?
Yes, sir. Good afternoon, sir. Sir,
Yes, please you share.
I'm not able to speak because.
Okay.
Hello.
Okay.
Sir,
Mohai,
sir.
Mohai Menul Bishas. Hello, Mohai Menul. Tapos Day.
Yes, sir. Actually, it is very interesting workshop that we have attended, and means I have learned a lot of things related to the psychometrics and this item response theory. And actually, I am very new in this field. Very thankful for organizing this such kind of interesting and engaging workshop. Hope that means in future we will be means we will get be benefited from you this by this such kind of things. Thank you. Means thanks a lot for all of this.
Thank you, Tapos Day. Gayatri. Hello, Gayatri. We have not received anything from you in the Google Classroom. Okay. Now, Mona Lisa Pattanayak.
Good evening, sir. Good evening, everyone. I am Monalisa Patnaik. I learned many new things in this 2 days orientation training on advanced applied psychometrics. So we learned from the basic to advanced level of psychometrics. Definitely our script which we learned 2 days by Dr. Rai sir and Madam Susmita Chatterjee madam. This is very helpful for me as a researcher. I am doing the research in AI technology, so structural equation modeling, I am doing that thing. So really it will be helpful for me. Our script I learned from madam. And sir.
Okay, thank you, Mona Lisa.
Thank you,
Lovely,
sir.
Lovely Divedi, please you. Lovely, are you here?
Yes, sir. I'm there, sir. Am
Okay.
I audible?
Yeah.
Yes, sir. So this session, which we all, as some of the students and all scholars, which we all are taking, so this session was really very helpful. And whenever and wherever doubts were there, I asked the doubts from you and ma'am, two of the teachers, those who were the presenters. Everything was presented in a good manner. The language was also good, and kind of strategies you were using, I mean, the session which was taken by ma'am today, it was very good because side by side ma'am was also, the commands which we need to use, and kind of she was also she was not only explaining everything to the point, and side by side she was also showing us the kinds of commands which we need to use, like one should proceed for everything. So in short, everything was good, and it was a wonderful workshop. So because this, for me also, this is my first statistical workshop which I'm attending, and statistics has been a, it's there in my psychology, and it's there. So I can also correlate with certain things which I've learned, and I also learned many new things from this workshop. It was really awesome and very good experience, sir. Thank you so much for to you and to the entire team, those who have been there in organizing this workshop. Thank you so much, sir.
Thank you, lovely. So now I am telling the name. First one, Okshita Bindal. Thank you, Okshita. We have evaluated your answer. Ananya Agarwal, Babita Biswas, Debjani Banerjee, Farah Ahmed. Okay, Farah, please you share. Sorry, we have not asked you.
Yes, sir. I want to express my gratitude to our dedicated instructors for their guidance. I feel truly fortunate to have had the opportunity to learn from them. The knowledge about both the theories now helps me to design adaptive assessment that truly capture individual abilities. And exploring this cluster analysis has been fascinating. This reveals hidden patterns within data, so I will apply this knowledge responsibly and contribute to the field of applied psychometrics. Thank you, everyone.
Thank you, Farah. Acha, Kobita Sahu, Lovely Divedi, Madhuri Nondi, Monalisa Pattanayak, Mr. Anthony, Ramia Shekhar, Tapos De, Mohai Menul Bishwas, Rambabu Morjo. Barsha, we have not received anything from you, so please you finish. Okay, Barsha.
Sir, last one I'm about to submit, sir. Before that one I have submitted, sir. That one I have just now submitted in the doc form, sir.
Okay. We will evaluate and we will announce. And we will send you the certificate to your email. So,
Yes, sir. Yes, sir.
okay.
Okay. Thank you so much, sir, for this opportunity.
Yeah, we are also grateful to you for the interaction because we have understood your requirement. We have tried our best.
Thank you so much, sir. Looking for more such opportunities, sir.
Okay. Good night, everybody.
Can we
Thank
have
you.
group photo? Sir,
Yeah,
can we have group photo?
Okay. Okay, group photo.
Yeah.
So please you open your video.
Yes, sir.
Mona Lisa is requesting you. Mona Lisa, are you taking the photo, Farah?
Yes, sir.
Yes, sir.
Farah, please take the photo.
Oh, sorry.
Thank you, lovely. Thank you, Shita. Rambabu, please open your video. Babita, Gayatri, Ananya.
Sir, I'm unable to take the photo. So can you?
Okay.
Sir, I am doing that.
Mona Lisa is taking the photo. Okay.
Yeah.
Yes, Ananya Agarwal, thank you.
Thank you.
Thank you, everybody. Good night.
Thank you, sir.
Thank you, sir.
Good night.
Good night.